Okay, this is the last video in the last section of your notes. I can only record 15 minutes at a time, so I hit right at 15, so I needed to create a new video for this last section. So it says examples 6 through 10, but these are examples 1 through 5. I don't know. So we're going to use this cosine graph. I pulled this. You should have your own, so you can just look up above at the top of the page. Yours is probably even more precise than mine is. So if we go ahead and we're asked to evaluate the cosine at negative 3 pi over 2. So negative 3 pi over 2 is on our graph, so we don't really have to worry that much. So if I go over here, my negative 3 over 2 is right here. Okay, so my negative 3 over 2 ends up giving me 0. So if you look, my graph's a little bit off because I can't tell exactly where it is. But if I go in there, it just gives me 0. So easy enough. We didn't have to figure out how many cycles there were. We just had to straight look at the graph and figure out where 0 was. Or figure out where negative 3 pi over 2 was. It was at 0. So example 2, find cosine of 7 pi. So again, I want to figure out how many cycles that is. So if I look at 7 pi, I think 6 pi plus pi. Okay, 6 pi is divisible by 2 pi, so that would tell me how many cycles it is. So I always try and get an even number. So it tells me there are 3 cycles in this, and then pi. So plus pi. So I'm actually trying to find the cosine of pi. So if I go back up to my graph now, so I go over pi amount, all right, and then I figure out where my graph lies. So if you look, here's my graph, and it looks like it's at negative 1 to me. Yours is even more precise than mine, so negative 1 is the correct answer. Okay, so first figure out how many cycles it is, and then you got to figure out where it lands on this graph. So example 3, so it's 15 pi over 2. So maybe I think, okay, well, that's a hard part to think there. So maybe I think 14 pi over 2 plus pi over 2, because 14 plus 1 is 15. That ends up giving me 7 pi, which, again, 7 pi ends up being 3 cycles plus a pi. So if I combine my 2 leftovers, I have pi and pi over 2. Okay, I always get it to an even number, and then that one I had to convert. So I'm really looking for the cosine of, that's 2 over 2, I get 3 pi over 2. So I'm really looking for the cosine of 3 pi over 2. So again, if I go back up to my graph and I go the whole way out to 3 pi over 2, looks like we are at 0. So that's my answer there. Okay. Again, because it repeats, I can just kind of take out those cycles and find what was left over. So 4, it says find the values of where the cosine of theta is 0. So just like I did with sine, I'm going to go and figure out where my cosine lies at 0. So here it's at 0, here's a 0, here's a 0, here's a 0. So if you look, I'm at negative 3 pi over 2, and all the ones before it. I'm also there at negative pi over 2, and I'm there at pi over 2, positive pi over 2, and then also at 3 pi over 2. And it would keep going in that pattern. So if I want to figure out what the pattern is, this space between these, the space here is only pi. So each time I'm either adding or subtracting pi. So I started with pi over 2, so I do pi over 2 plus or minus pi times k. Remember, k is an integer. Just make sure I got that right. Yep. So that would be the... All right, so go ahead and look at 5. I think I might have messed up my timing, but we'll see if it works out. So example 5, it says the cosine is -1. So if I go up here and I'm looking for -1. Alright, so -1 is here and -1 is here. If you look, the distance between this is 2 pi, and I'm starting at pi. So every 2 pi, I'm going to end up down here at -1. So the generic case, so if you look, the only ones that are on my graph are at -pi and +pi. So now I can say, okay, well, I started at pi, and then I move 2 pi every time, so plus or minus 2 pi times k. Again, k is an integer. All right, and that's the end of your notes.